Dear Patreon members, this video is for you guys. Here we'll do question number 1 to question number 10 from the 100 integrals, and make sure you guys check the attachment for the questions and also my handwritten solutions. For the first one, we have the integral of tangent to the 5th power x times secant to the 3rd power x. Notice both of them are to an odd power, right? So we are going to take out one factor from each. We will get the integral tangent to the 4th times secant to the 2nd, and then we need another tangent here and also another secant here. Now notice the last part here, we have tangent x times secant x. So our goal is to write the first part in terms of secant x, because the derivative of secant x will give us precisely this. So to achieve that, let's look at tangent to the 4th power and rewrite that as tangent square and then square. And here we will have to know our trig identities. Tangent square x equals secant square x minus 1. And we still have the square, and then we are just going to write down the rest. And this is great, because now we are ready to do a u sub. Let u equal to just secant to the 1st power, because when we differentiate that, we get precisely secant x times tangent x dx, which is this last part. So we can take this integral to the u world. Secant is the u, but we have u squared because that's secant squared. And then minus 1 squared, again another u squared, and then the last part is just du. And to finish this, we are going to first expand this out. So we have to square this, and then we get u to the 4th power, and it's a minus 2 times this and that, so that's 2u squared. And then lastly add 1 squared, which is just 1, and then u squared du. Then distribute the u squared. We are looking at the integral of u to the 6 minus 2u to the 4, and then plus u squared. We are finally ready to integrate, right? When we integrate u to the 6th power, we will get 1 over 7 u to the 7th power, and we know u is equal to secant x. So I'm just going to put that down right here. Secant, and then 7, and then the x. And then continue with the rest. Next though, add 1 to the power is 5, divided by that, so we have minus 2 over 5. U is secant, and then here we have the 5th power, and lastly 1/3, and then secant, and then to the 3rd power. And then we're all done, so I'll put a plus c at the very end. This is it. Now, number 2. Here we are going to integrate cosine of 2x over, we have sine x plus cosine of x. The 2x instead of the cosine is suspicious, right? Yes, we are just going to use the double angle identity, and the version that we are going to use is the following. I'm going to break this down by looking at this as cosine square x minus sine square x. Because the top is actually just a difference of 2 squares, meaning we can actually just factor it. So this is the integral, and then we will have, if we factor that, we just get cosine of x minus sine of x times cosine of x plus sine of x over the denominator. And then, ladies and gentlemen, this and that can cancel. The order of addition doesn't matter. So we are just going to integrate cosine of x minus sine of x. And when we integrate cosine, we get positive sine. when we integrate negative sign, we get positive cosine. And then we are done. So put a plus c. That's it. Now, number 3. This right here, it's a little bit trickier, especially if you haven't seen this kind of style before. Well, let me show you. We have x squared plus 1 over x to the 4th power minus x squared plus 1. So notice that we just have x to the even power, right? In this kind of situation, for this particular one, we are going to divide the top and bottom by x squared. And then algebraically, you will see it will work out very nicely. Let me write it down for you guys. This is the integral. On the top is 1 plus 1 over x squared. On the bottom, when you reduce that, you get x squared minus 1 plus 1 over x squared. Now, the key is the bottom here. So I want to show you guys this on the side. We know that if we have a squared minus, because that's a minus right here, so I put on the minus version, minus 2ab, and then plus b squared. This will just be a minus b squared after we factor it. Okay? Now, we have x squared, and I'm just going to look at that as x squared, and then 1 over x squared, I'm going to look at that as 1 over x and then squared. Well, if I want to match with the formula I put down right here, don't I just need the middle part? Sure thing, right? That means I need to have a minus 2, and the a is the x, and then the b is 1 over x. That's all I need. So, if this is the expression, we will be able to factor it and get x minus 1 over x squared. Good. And now, notice the middle term. This is really just minus 2 because the x and x cancel, right? What do we have here? This is a minus 1. So, what we are going to do is, let's just minus 1 here so we can end up with minus 2. But of course, we will have to add a 1 at the end so that we are just adding 0. This way, we can see that on the top stays the same. But on the bottom, I'm just going to have this right here. X squared minus 2, and then plus 1 over x squared, and then plus 1. Okay, so the blue part will give us exactly what we went over earlier. And that is going to be x minus 1 over x, and then squared. I'll put everything in blue actually. Perfect. And then after that, we have a plus 1 dx. Okay, now what's so good about this though? Well, I will tell you, because now we can do u sub. That u equal to the inside of the parentheses. When you differentiate that, you get precisely 1, and then look at this as x to the negative 1 power. Bring the negative 1 to the front, you get a positive. And then negative 1 minus 1 is negative 2, so it's 1 over x squared dx. And that's exactly what we have right here. Yes, that is our du. So all in all, this becomes the integral of, let's put a 1 right here, and then the du on the side. This is just the u for the inside, and then we have the squared, and then plus 1. And is this something that we can integrate? Yes, the derivative of what will give us this? Inverse tangent, yes. So the answer is just going to be inverse tangent of u, and u is equal to what? Well, just that expression, right? X minus 1 over x. And then we're done. Plus c. Just like that. Now, number 4. Here we have the integral of x plus e to the x squared. Well, don't need to do any substitution. It's just a matter of multiply it out and then integration by parts. So when we expand the binomial, we square the first, and then we add 2 times the first and then the second, and then we add the square of the second. E to the x squared, we multiply the exponents, so that's e to the 2x. Okay, integrating the first one, that's just 1/3 x to the third power. Now, for the next one, when we integrate 2x times e to the x, this, we need to use the integration by parts. And let me just write it down right here for you guys real quick. Integral of 2x e to the x. Do integration by parts, of course, let's do the di. Plus or minus plus, right? I'm going to do 2x for the differentiation. I'm going to do e to the x for the integration. Differentiating 2x, one time we get 2. Do it again, we get 0, so we can stop. Integrating e to the x is just always e to the x. Now, we do this times this, and this times this. And don't forget the sign in the front. So, that's the answer. The first part is all that. So we will have plus 2x e to the x. Next we have this, which is minus 2 e to the x. That's pretty much it. Then integrating this is going to be plus 1/2 e to the 2x. And then we're all done, plus c. Right here though, I just want to make a real quick note for you guys. Whenever we are integrating e, if it's a number, let's say a times x to the first power, what we are going to get is just e to the ax, and then just multiply by the derivative of, well, divided by the derivative of ax, which is just a, divided by a is the same as multiplied by 1 over a, because of the reverse chain rule. Whenever the input is just a linear function, you can always do something like this. That's how we get the 1/2 right here. Okay. Next one, we have what? Number 5. Integral of cosecant to the third power x times secant x. Okay, one of the harder one because you have to just do enough trig identities till that you can see something that you can actually integrate. So let's do that. I'm actually going to work with sine cosine only. That's usually a good strategy. So I will rewrite this as the integral, and then we have 1 over sine to the third power x times cosine x dx. For now, we cannot do u sub because unfortunately the cosine x is on the bottom. Do not say u is equal to sine x. That doesn't help. What we are going to do is, I'm going to look at the 1, because everybody knows sine squared plus cosine squared is equal to 1. But I know 1 equals sine squared x plus cosine squared x. This will allow us to have more things to work with. I am actually going to split the fraction here. We will have the integral. Let's look at sine squared x, and I'm going to put that in red. And then over the denominator. And then plus the other part, which is cosine squared x, and over the same denominator. Have a look. We can cancel out some stuff, right? Sine squared, and 2 of them can cancel. And then right here, cosine, and 1 of them can cancel. Pretty good. So we are looking at, for the first one, we get the integral is just 1 on the top now over sine x times cosine x. And then for the second one, we have cosine of x over sine to the third power x. For this one, we can do a u sub, let u equal to sine x, because the derivative is cosine x, and then that will be the du. But for this one, well, we are going to do what we did earlier. 1 is the same as sine squared x plus cosine squared x, and then split the fraction again. Have a look. This will give us the integral, and then for the first one, I will have sine squared x over the denominator plus the next one, which is cosine squared x, and then over the denominator. And then the last one, let's just keep it. Dx. Now, ladies and gentlemen, let's cancel things again. Sine of x, one of them cancel out. Cosine, one of them cancel out. So if you look at the first part, this is the integral. We have sine x over cosine x. I can look at that as tangent x. Next, cosine x over sine x. I can look at that as cotangent x. And the last one, keeping that form. Okay, the integral of tangent x, you can just quote the standard result. It's either you write negative ln absolute value of cosine x, or you put a negative to the top and you get secant. That's actually the standard result, so I'll write it down like this. And then the standard result for the integral of cotangent x is ln absolute value of sine x. And those could be done by u sub. In fact, you can just do the u sub right here. Let u equal to cosine x, and then you have the sine x on the top, waiting for you to work with. Likewise for this part as well. For this one, I will just show you guys this real quick. We will have to do a quick u sub, u equal to sine x, just the first power, so that we can get du equal to cosine x. So this becomes the integral of u to the third power on the bottom, and then du. And then that's integral of u to the negative 3. Add 1 to the power, we get negative 2. Divided by negative 2 is 1 over negative 2. And then u to the negative 2 power. So for the last one right here, we have a minus 1 over 2. And then u to the second power, I'm just going to write it down like this. U is sine x, and then square like that. Yeah, just put it down like this for now. I will do a final change. Because the secant x, it's the same as 1 over cosine x. And then we can put the first two ln's together. In that case, we get ln absolute value. We are going to just multiply 1 over cosine x and sine x together, which we get sine x over cosine x, and that's just a nice tangent x. And then we have minus, let's put on 1/2. We have sine square on the bottom, which I can write it as cosecant square, like so. Done. I will only put on the plus z at the final end for the answer. So that's it. Ooh, a tough one, right? Now, number 6. Here we have the integral, and we have the sine cosine again. Cosine x over sine square x minus 5 times sine x minus 6. Just do a u sub. Let u equal to sine square x, because we have the cosine on the top waiting for us. Right? So, have a look. This, we can go into the u world right away. It's just going to be u squared minus 5 times u, and then plus minus 6. And then that part is just the du. I'll put it on the side. And now, notice the bottom is factorable. We will just get u plus 1 times u minus 6. So, that means we can do partial fractions. We will have two little fractions, with the first one have the denominator u plus 1, and the next one u minus 6. Well, because they are both linear on the bottom, that means the top will be constants. Now, to figure out a, this is what we can do. Let's do the cover-up method. Well, if you go back to the original, I'm going to cover out the same denominator, which is the u plus 1. Now, we will have to think about how can we make u plus 1 equal to 0. U has to be negative 1. So I will let u equal to negative 1. And then we will have to plug that into here. So we get 1 because of this right here, over u is the -1, and then minus 6. Work that out, we get -1/7. So this is the carve-out method to figure out the coefficient that we need for the partial fractions. Let's practice another one for the b. b equals, we'll do the same thing. Cover the same denominator from the original, which is the u minus 6 here. And then this time though, if we put this equal to 0, u has to be 6, and then put it here. So we are looking at 1/6 plus 1, which is 1/7. So we know a is -1/7, and b is positive 1/7. And let me also give you guys a quick review. We have linear on the bottom, right? So when we have an integral of a linear function, let's say ax plus b, we are going to get ln absolute value of ax plus b, and you will have to divide it by the derivative of this, which is just a coefficient of x. And of course, right here, we have to say a is not equal to 0. Otherwise, it's not a linear function on the bottom, right? But anyways, though, for this one right here, we are going to have the following. Let's put on the constant multiple first, which is -1/7, and then ln absolute value. Here we have the u, which is sine x, and then plus 1. And then next we have plus 1/7, and then again ln absolute value u minus 6, and then we know what u is, which is the sine x, and then minus 6. All done, plus c. Done. Of course, you can also choose to combine the ln's together, but I will leave that to you. Now, number 7. Integral of 1/square root of e to the x. We don't have to do anything too fancy for this. It's just a matter of knowing the square root. It's the same as the 1/2 power. So we are really looking at this as the integral of, let's write this as the 1/2 power. And then we have e to the x on the inside. And then multiply the powers. So it's just e to the 1/2 power times x. Now, we can bring that up, right? And we will just have the integral e to the negative 1/2 power times x. Yeah, 1/2, negative 1/2 times x. Well, isn't this one of the nice one that we know? Yes, right? Note that if we have the integral of e to the ax, this right here is just 1/a e to the ax. Here, the a is -1/2. So divided by -1/2, it's the same as multiplied by -2. And then the function part, this right here, stays the same. Yeah, you can just leave the answer like this. Or, of course, if you choose, you can bring this back down again. So this right here actually becomes -2 on the top, and then over square root of e to the x. Same thing. Okay, number 8. This is a big one. We have the integral, and then we have e to the x times the square root of e to the x minus 1 over e to the x plus 3. Okay, we have a pretty complicated function with square root. Trig sub is not going to work out nicely because the input here is a e to the x minus 1. It's not like something to a second power, right? So don't do trig sub. Here's a usual strategy. Try u sub, let u equal to the whole square root, and then we will see how to go from there, right? And perhaps I'll actually put the u right here. No, actually I'll leave it, yeah, I'll just do here, okay. Now, put on u and then differentiate that. The derivative of square root is 1 over 2 square root of e to the x minus 1. And don't forget the chain rule. The derivative of the inside gives us another e to the x. Now, to get dx by itself, we will have to multiply the reciprocal of this to both sides, meaning this will be on the top now, and then this will be on the bottom. Okay, then we can go to the u world. We have the integral. On the top, let me keep the e to the x. And then for the square root part, that's the u. And then for the e to the x, I'm also going to keep that. And then plus 3. And then the dx is exactly what we found right here. Let's see if this works out nicely. First, e to the x and e to the x, they do cancel out nicely. And the square root of e to the x minus 1, that's our u. So that's also pretty good. But we do have this e to the x. That's not allowed in the u world, right? Sorry, it should be a u right here. So what can we do? Well, let's go back to the definition of our u. Square both sides, we get u squared equals e to the x minus 1. And then we can just add 1 to both sides. So e to the x equals u squared plus 1. So we can actually just replace this right here with u squared plus 1. Now, let me work this out carefully for you guys. First, we have a constant multiple 2. Let's put it on the very outside of the integral. And then here we have u times u on the top. So on the top wise, we will have u squared. And then on the bottom, notice we have u squared, okay? And then 1 plus 4, the 1 plus 3, which is 4. And then in the u world, right? The 1 plus the 3, we get the 4. Now, notice the degree on the top is 2. It's the same as the degree on the bottom. So you can do a polynomial long division, or you can also do it this way. Make things happen. Let's just go ahead and add 4 and minus 4. Because this way, if you look at this term, that will just be 1. And then this is very nice to integrate. So we still have the 2 all the way in the front. And then we will have 1. And then perhaps let's close that. And then actually, let me just write it like this. 1 and then minus 4 over u squared plus 4. Now, let's put down 2 parentheses for the result of the integrations. Integrating 1 in the u world, we get u. And we have to have the negative 4. And now, let's talk about how we can integrate if we have the, let me just write this down. If we have integral of 1 over u squared plus the 4 is like 2 squared. The formula is, we are going to be using inverse tangent. There's a plus in between, so that's the inverse tangent. We will end up with 1 over 2, and then we will have inverse tangent of u over 2. And the general formula is this, with a, but it's really just the same thing. It's 1 over a, inverse tangent of u over a, and then plus c. All right, so all that here, we will have to have the 1/2 and then inverse tangent and then u over 2. But perhaps I'm not going to put on the plus c here because that's not really the deal. And then let me just reorganize the steps. I should have shown you guys the formula first, but if you see the 2, you see the a, same thing, right? Anyways, the final step I'm going to do is just distribute the 2 and then just put things down nicely. So first, 2 times u, is 2, and then the u, if we look back, it's the square root part right here. So square root of e to the x minus 1. And then next, take this times that. You can just cancel out the 2 and then the 1/2, so you'll just end up with the minus 4. And then inverse tangent. U is once again the square root of e to the x minus 1. And then we have the over 2. Done. Okay. All right. Number 9. Here we have the integral of 1 over x plus square root of x. Now, please do not get too excited and just say this right here is equal to ln of absolute value x plus the square root of x. Maybe you remember the plus c, but no, this is incorrect. You only get ln if the bottom is a linear function ax plus b. Here we have a square root function, so it's not the ln case. Well, how do we do this though? For this one, we can factor out a square root on the bottom. Let me show you. So square root of x, because square root of x times square root of x will give us the x, right? So we have that, and then plus 1. If you do it this way, you can see that if you put u equal to the inside parentheses, and for this one, depends on how you like to do it. You can differentiate this now, or you can solve for x and differentiate about the same difficulty, I would say. I'm just going to differentiate this now. So du is equal to the derivative of square root is 1 over 2 square root of x, and then dx. And now dx, multiply this to both sides, and then we have that. So if we take this to the u world, we have the integral 1 over, we have the square root of x, and then here we have the u, and then dx is the 2 square root of x du. Works out pretty nicely, right? Because square root of x and that square root of x, they cancel out very, very nicely. So now we can put the constant multiple all the way in the front. Integral of 1 over u is ln of u, absolute value, right? What's u though? U is 1 plus square root of x. So I'm just going to put that down right here, like this. Now, because the output of square root is always positive, it's always non-negative, and then plus 1 to it, it's always positive. So the absolute value is not needed. I'll just put down parentheses, and then we are done. Put a plus c. Yes, you still get the ln, but no, it was not this one. That was bad. Okay, number 10. Here we have a definite integral going from negative 1 to 5. And then we have absolute value of x minus 3. For this right here, because it's definite integral with absolute value, use area. It's going to be much easier. So let me show you. Firstly though, we need to know the graph for absolute value of x. It's just our typical V shape like so. And I'm using a graph paper because that way you can see this is like 1, 2, 3, and so on. Very nice, right? So this is absolute value of x. Now, if we have to graph absolute value of x minus 3, we have to move this graph 3 times to the right. So the vertex is right here, and then you still have the V shape like this. It should be like this, and then it should be like this. It's a 45 degree, and also like this right here should also be 45 degree diagonal because the slope right here is 1. Okay, so this is y equals absolute value of x, and then we have the minus 3. We moved it to the right 3 times. Now, we want the area under the curve from negative 1 to 5. So -1 is right here, and then 5 is right here. So we just need all this area. So we have 2 triangles, and they are very nice. They are just right triangles. And of course, this part right here is 3. So from -1 to 3, the whole distance here is 4. I'm just going to label it like this. And then -1, to get the y value, you can plug into the function. You'll get 4. So for the first area, I'm just going to kind of shade this in red. We are going to get half of base times height, which is just 4 times 4. And then we will have to add that with the next area from 3 to 5 is 2. And then when you plug in 5 into this function, you will get 2 right here for the height as well. So for this area here, half of base times height. So we have 2 times 2. So now we just have to work this out. Half of 4 is 2. 2 times 4 is 8 plus 2. So altogether is 10. So the answer is 10 for that. That's it.